Okay, now we're going to be using a new property called the quotient property of radicals. So this quotient property, and we have our defined variables up here, but the quotient property says if you've got a radical over a radical and they're the same index, then that's the same thing as if we were to take the square root or the cube root or the whatever the root was of those radicands divided. So we can either put it together as a division or we can separate it as dividing two radicals. Then it goes forwards and backwards. We can either, and sometimes it's easier to divide the numbers first and then take the square root or the cube root, whatever. Sometimes it's easier to take the root of each one individually. So we're going to be playing with that. Okay, first of all, we have this one that says simplify the square root of 3 over 16. Now we can't do anything, we can't reduce 3 over 16 down any at all, but because of those rules, right now we have one that's put together. We can actually separate it out as the root of the numerator and the root of the denominator. So this would be the same thing as saying the square root of 3 over the square root of 16. Now I wanted to do that because the square root of 3 we can't do anything with. But look, we can take the square root of 16, that's a 4. So simplified, this would be the square root of 3 over 4. Let's do another one. Here we have this one that says the fourth root of 2a to the 8th over 81. And again, we can't really do anything to simplify 2 over 81. So maybe we should separate this out into two separate radicals. Let's do the fourth root of 2a to the 8th over the fourth root of 81 and see if that helps us. Okay, well, if I look at these a little at a time, we can't do anything with the fourth root of 2. That's 2 is not a perfect root there, or perfect power. But we can take the fourth root of a to the 8th. Because remember, 4 will divide into 8 2 even times. So this will come out as an a squared over the fourth root of 81. Is 81 a perfect fourth power? It absolutely is. 3 to the fourth is 81. So going backwards, the fourth root of 81 would have to be 3. So this is the simplified version. Now lastly, we have this one. And again, we can't reduce down 4 and 81. So let's change this into the square root of 4a to the 4th over the square root of 81b squared. And let's simplify what we can. We can take the square root of 4, that would be 2, and we can take the square root of a to the 4th because 2 goes into 4 2 even times. Divided by. Now we can take the square root of 81, that's a perfect square, that would be 9. And the square root of b squared, well, remember those cancel each other, so that's just a b. Or you could look at it as 2 goes into 2 one whole time. So that would be b to the first. So simplified, we have a 2a squared over 9b.